Okay, so this one is quick. Here's another one of my phrases. Okay. Well, this is not a phrase yet. When is a model a good model? A good model should explain all the patterns. Explains all the patterns. In this case, problem 12, it's called a residual plot. Residual plot, this is a plot of the unexplained. Okay, so a residual plot tells you what the unexplained is. So, what if the residual plot looks like this? If the residual plot looks like this, okay, is there a pattern in the residual plot? Yes, there is a pattern. Okay, that means the model is incomplete because there is a pattern that the model hasn't explained yet. So if to get back to the residual plot, if there is a pattern, then the model is not good. It's incomplete. Now, what does a good residual plot look like? It looks like something with no pattern. Okay, so I just drew a bunch of dots. This has no pattern, which is good. How do I describe no pattern? I just describe it as a Cheerios plot. So for those of you who have little kids, say your little kid has a bowl of Cheerios, flips it over on the ground. The Cheerios run all over the place. There is no pattern. Good residual plots look like Cheerios splatter. So here's a plot here. Do we see any U's? Do we see any patterns? To me, this looks pretty good to Cheerios. Okay, the points are scattered all over the place. So this one is pretty good. Let me draw you the three kinds of patterns that are not good. Okay, what do they mean by constant error variance? So this is still number 12. Constant error variance. That's what happens when the residual plot fans out. And this is bad. The residual plot does not fan out. And when your kid throws Cheerios on the floor, it doesn't spread out into a fan. It just spreads out all over. This is bad. Pattern residuals, that's like the horseshoe or the U. You see a pattern. And this is bad also. Pattern means we missed something. A fan like this means it's not going to satisfy our statistical requirements. Remember way back in week 3 or so, we had to check that the binomial Pn minus P, or Np1 minus P was more than 10. We had to check that at least we had 30 observations in a mean. So now and again, we have to check certain statistical requirements. A fan violates one of the statistical requirements. An outlier, well, you can guess what an outlier looks like. Most all the residuals are here, and there's 1 point out there. So if there's 1 point out here, that means there's something screwy going on, right? There should not be 1 point that is way off from everything else. So in this case, are there any outliers? These 2 points are vaguely outliers. We could probably do a test to see if they're outliers or not. For me, I'm not sure. Could be one way, could be the other. Definitely no pattern, definitely no fan. So my guess, are these 2 outliers? Maybe. So I would guess maybe they're outliers. Okay, so my stat lab also wanted these to be outliers. The problem about guessing outliers in this course, there are some informal tests for outliers to suggest whether a value is an outlier or not. However, we didn't do any of them. So we don't have any mathematical way of judging whether something is an outlier or not. So for us, it has to be just eyeballing it. In some cases like this, it depends on who you talk to. I wouldn't be too worried with 2 points out like that, but probably from an official point of view, those would be outliers.